Morning, ladies and gentlemen, or Borodo. Um, Today is July the 3rd, 2022, and you are watching this video probably on my channel Res Admirabilis, and I would like to show you how to assemble a real perpetuum mobile, or free energy generator, as they sometimes call it. And what you see is based on the works of Nikola Tesla. So maybe at first a few words how it works, and I'll try to explain the principle. What you see here is called Tesla switch, and here is the diagram. It usually consists of 4 batteries, like these 4 batteries, and the switch itself, which is in this schematic diagram, formed of a relay with 3 groups of contacts, is switching the 2 leftmost batteries in series, while the 2 right ones are in parallel, and vice versa. So when these batteries B1 and B2 are in series, they are 12 volts batteries, so they generate 24 volts, about 24 volts, while the voltage of these two, since they are connected in parallel, is 12 volts. So the potential of the left 2 batteries is 24 volts, and the potential of the right 2 batteries is 12 volts. And this voltage difference is feeding the load, which is between the anodes of the upper 2 batteries. And when the switch is switching the right 2 batteries in series and the left 2 batteries in parallel, the voltage here on the right is 24 volts, and the voltage here on the left is 12 volts. So the current would change its direction, and these batteries on the right would charge the 2 batteries on the left, and so on and so forth. So this is the principle of the Tesla switch, which means that the energy is not lost, and the whole design is based on the law of conservation of energy. Therefore, this perpetuum mobile, or free energy generator, why it's not proper to use the word generator, because Tesla himself wrote that the energy cannot be generated because it's conserved. So well, the idea is that instead of being lost in some chemical reactions, the energy from the batteries in series is charging the batteries in parallel, and so on. So it's not lost. And in my previous videos you might have a chance of observing that Tesla switch is working very precisely and very accurately, and this is true. So each time it switches at the same voltage up to 1 hundredth of volt. Well, as to the design of the circuit that switches the batteries, here it is. You may copy it. It's and use it for yourself. It is based on the 555 timer, NE555N, of a good brand name, so it could work reliably. And you see, if you add these resistors and 810 kilovolts and 2 mega ohms and 47 microfarads, you would have the switching each minute and 6 to 7 seconds or so. So about each minute the Tesla switch, being driven by this circuit, is switching the batteries from parallel to series and back. And the energy is circulating in this circuit, as you can see. So basically it would circulate eternally if there were no self-discharge in the batteries. However, at some designs it could be compensated or even overcompensated, and the device would become well, self-multiplying its own energy from scratch, which is not quite what I would like to reproduce here, but this switch would definitely have some minute losses as a self-discharge. So how to compensate them we'll discuss later, and how to turn it into a real perpetual mobile. And because of the fact that the current is changing its direction in the load between the two positive poles of the two upper batteries, it is necessary to rectify it. And the second relay, we remember that the first relay is actually doing the switches. The second relay is rectifying these pulses into a constant voltage. You could see that whatever is the voltage on these contacts, on the middle contacts of the second relay, the output voltage is of the same polarity. And this part of the circuit reminds us that we should not leave the relay contacts, relay coil contacts, connected directly to the transistor that switches them, but add a diode that would return the energy back to the source instead of overloading the transistor with that high potential. So this is about the theory, and that's how it works in practice. At least in my realization, you could easily create your own. Just remember the main principle: batteries in parallel and batteries in series, and the switch is switching them. It is necessary to switch them because otherwise the batteries that are in series would probably overcharge the batteries that are in parallel. So from time to time we need to switch them back and forth. And this is the actual batteries, and like you see 4 batteries, and the fifth one, its role will be discussed later. We will connect it later to the main body of the switch. And this is the box which contains the physical realization of this circuit that you were just observing. And if we remove the lid, we see that the circuit is composed of that controller built on the 555 timer. Yeah, here it is, just a moment. And it is protected by the diode bridge and the capacitor, which would accept the energy returned in during the switches of the relay coil. And it consists of two relays. The first one is the switching relay, and the second one is the rectifying relay. And it is important that both relays would be of the same type, approximately of the same brand name, and of the same current. These relays are for 10 amperes, and they should perfectly fit with the demands of this Tesla switch. If 10 amperes or 120 watts is probably a good value, but still not enough, this energy, this power could be multiplied later after the switch is working. The best way after the box is, well, you might easily, of course, assemble your own according to your wishes. Just remember the principle, how it should work. And I found it very useful after burning quite a few expensive components, that each wire is marked with the coordinates of the point of the batteries that it should be connected to. And besides, each wire is carefully separated from other wires, because otherwise it could easily produce a short circuit, which is not what we want. Because this device is looking very peaceful, but remember that it could easily generate a current exceeding 500 amperes, and these thick wires would be not just melted but probably evaporate. So I don't want to do that, definitely. So it is important to work as carefully, as diligently as we can. Remember, this, it looks like it's not like quite a toy, but it looks much less serious than well, it actually is. It's Tesla, after all. So the first, let us look at the circuit. The first thing we should connect to, we should connect two negative poles of the batteries together. Here they are. So that's what we are doing now. We have a wire for that, and that's what we do. These are negatives. I found that the minus might not be quite noticeable, so I put pieces of green insulating tape on it. So we are connecting the negative poles of the two lower batteries. I found the idea that such an assembly might be useful, because you know what happened is that they are telling people that this is impossible to assemble a free energy generator. Well, let's use this term, well, even though it's not quite right. So we are connecting that, and we leave for the time being the nuts a bit loose because we might need to connect more. So now the two negative poles are connected, and we can go further. Usually I connect the two upper wires, these ones that are leading to load. I connect them last because I see the same circuit is fed from the load, so it's better to start all that at the last point. It just seems reasonable. So first we are finding the wires that lead to the these two batteries. Fortunately, this one just came the first. So B1 is this one, and plus means the plus, so we leave it here, and the next would be B3, B3 minus, this is B3 minus, and there should be B3 plus, just a moment, B3 minus, yeah, this is B3 plus indeed. So as I mark them as normally opened, and sorry, this is B3 minus. Yeah, just a moment. Yeah, this is B3 plus. So yeah, these two wires, B1, which are lead to the positive contacts, positive terminals of the batteries, of the upper batteries on the circuit. We leave the last to connect. And now we are connecting all the rest. So I just marked them when I was first assembling the thing. So I'm just connecting them. The order basically doesn't matter. For example, this means B4 plus, so B4 is this battery, the fourth one. 1, 2, 3, 4. This is the fourth, and this is 4 plus. Yeah, so the matter is that yeah, they were telling people that this is impossible for quite a long time, which is not quite true, fortunately. The first, or one of the first, perpetual mobile was built by Archimedes more than 2000 years ago, and this sphere is still available, and the sphere that Archimedes built was working a few hundred years, and there are multiple evidences about that. So okay, the next, these two wires that are coming from the another side are the output wires, so we won't touch them, and we have to pay every attention that they wouldn't connect in between while we are assembling the rest of the apparatus. Okay, so now it's these two are laying here, they are not connected. We check that the other ones are not connected. We check that the output wires are not connected, and now we are assembling the rest of the machine. Like this one is B2 minus. B2 minus is going to B2 minus, right? So here it is. After we connected two terminals we can fix the knot more tightly, because there is no more than 2 wires coming at any point together. Now this is B2 plus, B2 plus, so which means that it goes here, B1, B2 and plus terminal. I marked it with the red tape. Yeah. Then we found B1 minus. Remember we should pay every attention that they didn't contact themselves while we are assembling the machine. But after that, if you assemble it, everything is going to be fine, hopefully. B1 minus, which goes to B1 minus. When you are doing this for the first time, try to be careful and try to watch if there are any sparkles or signs of short-circuiting, because this is important. You could save your components and a lot of your money by preventing that. So this is B3 minus and B3 minus is, so 1, 2, 3. B3 minus, of course it goes here to the minus. Yeah. It goes to the minus. Alright. Then we have 2 more left. Only 2 more left, besides those 2 that are going to be connected, the last ones. So this is B3 minus. B3 minus is here too. Yeah, B3 minus green and B3 minus red. So we are connecting them. So yeah, it's a good idea, as I mentioned, it's a good idea to touch them to see if there are any sparks, which is not what we want. It should be assembled without any signs of unusual electrical activity. Yeah, maybe we could move them both and fix that screw. So there are 2 of them. Now the last one is B1 minus. B1 minus. Yeah, this is B1 minus. B1 minus green we have already read, and B1 minus goes to the first battery, remember. So yeah, you may touch, then nothing happens. So B1 minus, we connect them and we fix the screw more tightly. Now, as you can see, we have everything connected. Hopefully it's right. So we are tightening the nuts with just with hand, just to show you. Of course, you might take a wrench and tie them tighter. And the last ones are B1 plus and B3 plus. So B1 plus is going here. B1 plus, because this is the first battery. Yeah, and you've heard the sound. It starts switching intermittently, which is stopped after we connect the B1, the B3 plus to the terminal. And now that Tesla switch, it started operating, as you've heard, and it will switch itself once a minute, about once a minute, well, once a minute and 5 seconds or 7 seconds, about that time. If you assemble your circuit according to the drawing I presented, you would have the same result. And now, yes, we can, since it's working, we can connect a useful load to it. And in the previous video I showed you the detail voltage, how it works, and the voltage it generates on the two left batteries. So yeah, it shows that they are really switching from the 12 volt, from about 12 volts to about 24 to 25 volts. And for example, we could connect an inverter. Yeah, you heard that switched while I was talking. A minute has elapsed, so we could connect an inverter, and we could have a power useful for our household appliances immediately, which is why I'm showing you this Tesla design. He's got many types of perpetual mobile machine and electrical sources of energy, like apparently from nowhere, but he was telling us that this is from the ether, and we are living in an ocean of energy, and we can have as much energy as we want anywhere in the universe, at any point, at any time, as much as we want. And all that is true. Yeah, you heard it, you just heard it switched the second time. So now what we can do, we could connect the two wires, two output wires. Remember, these are two wires from the, this is the output of this box that is making actual switches. And here there should be 12 volts, and it is 12 volts indeed. We can check it very easily. We can check it by connecting this this inverter that is showing the voltage. This is a very nice device, and so this is the plus wire is marked with red tape, and the minus wire is marked with the green tape. Is there, and I'll take it later. So this is what I'm doing. I'm catching the red tape with the red terminal of this inverter, and the green wire with the black terminal. So I have to film with one hand and do all other things with another one. So we connected our inverter, so now we can switch. I recently repaired it. There was something wrong inside, so yeah, we could. Yeah, you see. Now it is showing us the power that is being consumed through the inverter. But if we close the contacts again, it will show you the output power and um, the input power. Yeah, so it is showing us. We could observe the voltage that is being produced by this Tesla switch. We'll wait a little bit, and generally it's pretty close. So as you can see, it is producing about 12 volts, a little bit more sometimes. Now what happened is that Tesla switched and the machine just shut down. Yeah, so there was 12.4, now it's 12.6 volts, because the batteries are a bit different. So they are producing, right now they are producing a bit different voltage, but with time everything should be should come to an equilibrium. And to avoid, as you can see, sometimes some inverters could just shut down during the switches because the relays are disconnecting the contacts momentarily. So to avoid that, we would connect the battery. Yeah, you see, that's happened again. It's just a momentarily disruption, but it might influence some of those. Yeah, the poor guy. He's complaining about being switched off. So now we are connecting the fifth battery that would stabilize the output, and it would allow us to avoid those possible troubles with our equipment, if you want to use the inverters, of course. Yeah, this is the fifth battery. It is a standard 12 volt battery, and we are connecting it in the same manner. The only thing is, we should be very careful, and we should indeed check everything we want to do before we actually do that. For example, we have to check that we have the plus contact being connected to the plus output, which is true. And now we are connecting this wire to the positive pole of the battery, and we may remove this cap, and the negative wire to the negative contact of the battery. So our battery will serve as a stabilizer. It would allow us to have 12 volts all the time, and it actually works as a load for the Tesla switch. Because what happens now is that Tesla switch is applying its energy to the batteries, charging it. So we can, a bonus is that we can have sometimes much more power that Tesla switch would be able to generate. So now if we now connect our little inverter remember, check again, this is plus, right? So we connect it to the plus, and this is minus. Usually, sometimes the inverters are producing sparks when they are being connected, so yeah, that happens. Yeah, you see. But this is the only spark that may be allowed during the assembly of the device. And now we switch it on. Yeah, now it is showing us the voltage 12.7, because and this is because this battery, the last battery, was recently charged by the inverter itself. I was trying to check to verify if it's possible that the inverter could recharge itself from its own energy, and this is true, it can, and I'll show you in a few minutes. So what do we have now is we have a fully functioning Tesla switch, well, a bit modified by myself, but it is based on Nikola Tesla ideas, as you saw. And this switch is able to establish the output of 1,000 times more energy than is being stored in the batteries, because as you could see in the previous video, that the energy that is produced by the batteries is not disappearing, is not being transformed, I mean, to irreversibly transformed into some chemicals reaction or to some heat, but it is fully recuperating by the batteries that are connected in parallel. Each time the batteries are connected in serial, they are doing some useful job and are charging the two batteries that are connected in parallel, and vice versa. That's why the only losses in this particular system, which could be also avoided, but well, they are here, might be due to the internal self-discharge. So well, as you see, if we put fully charged batteries to work here, with time, maybe in a few days, the efficiency of this Tesla switch would diminish because of the internal discharge. But right now it's like if I made this movie for, if I was continuing to shooting this movie for an hour or so, this output voltage probably wouldn't change at all. Yeah, we could, since we have our household power here, 120 volts in North America. In Europe you have probably 220 volt inverters. We could just plug in whatever we please. Well, say a lamp or whatever other device, and you could also arrange a self-charging of the Tesla switch by its own energy. In this way it would become a truly perpetual mobile, because while it's physically intact and all the components are in a good condition, it would never stop working. So how we could do that? We would connect the transformer, like any transformer, because we almost any transformer, because we do not need much power. Like this one is 120 to 220 volts, which is good because the charging device, which is this, it could work from 220 volts, 220 volts, as well as 120 volts. So we could plug in the transformer into the inverter, yes, and we could, but we haven't switched it on yet, and we could plug in the charging device, the charger, battery charger, and we could also, we could connect the terminals of the charger to the battery. Well, we could, for example, we could charge the battery number 2 or number 4 because they are connected together and they form kind of grounding, which makes sense. And why we are using transformer? Because it is necessary to galvanically separate. So you see we are attaching the clamps here. Again, check what you are doing. Black one should go to minus and red one should go to plus. If you do otherwise, which was, well, quite surprising, but I found that in some inverters at least it caused a short circuit, which was a very unpleasant experience. Yeah, so we connected this to the plus, to the minus. Now we are plugging in the inverter to the transformer. The transformer serves only the function of separation of so the device will not be galvanically connected to the circuit, and the whole Tesla switch would, so to say, think that this energy is coming from an external source. Now we can, yeah, you see, yeah, we switched it on, and the device is showing us the voltage and the power, the output voltage and the power. Yeah, 88 watts, which is good. So now we see that the battery charger started to work, and as you see, it is consuming the power and it is charging the Tesla switch itself, in this way compensating the losses for the energy that are occurring during the self-discharge of the batteries. And because I was charging this battery recently, just to check if it's possible, yes, it is possible. So yes, we can really have a real perpetual mobile or a free energy generator, and this is what exactly before your eyes at this very moment. You see there is not a single wire coming from the outside. Everything is produced by the device itself, and it does recharging itself with its own energy which is produced. And to prove that it can do that, and it can also do something else, we could put some useful load, whatever. Just a moment, I'll try. There is a lamp, so we could take a lamp. And yes, so I've just brought a lamp, and we could connect it to the 120 volt output of the inverter, and hopefully we could watch. Yeah, you see it's working. So yeah, now the thing is producing 130 watts of power. Yeah, imagine that. There is no external source of power, and this one. Yeah, so you may watch how the real perpetual mobile, electrical perpetual mobile is working, and built by the Tesla design. So later this energy that is being produced at the rate of currently 132 watts, or about 10 amperes, which is, I think it's a good like constant power for this device because of the capability of the batteries. So yeah, you could later this power, which is quite significant, but maybe not enough for most of our home applications, we could use for we could multiply. And Tesla has many designs for multiplying power, electrical power. It's amazing. It's really amazing. And if you multiply it like 10, 20 or 30 times, which is quite possible, we would generate a few kilowatts from this machine. It's quite compact, so I see no reason why you cannot build it for yourself. I gave you all the circuits, and I showed you how to build it. So yeah, you could build it and you could have your own power after multiplying, which can be done by using Tesla coils and volatile coils too, or both, or Tesla generator. Yeah, it's really exciting. So yeah, a few kilowatts would probably be enough for any household, and you could run your own home appliances on your own electrical energy. So thank you very much for watching this. Thank you very much for your time, and as an acknowledgement, I would like to express my my deepest gratitude to my school teachers. I was studying in a few provincial schools in western Ukraine, and the teachers were just amazing. And actually, I started working on this project since the age of 13, when I was discussing this subject with my school teacher in the grade, I think 7. So yeah, that was amazing, and I'm very grateful to my teachers that arranged my well, entering into school at the age of 5. So well, that's let's look once more at this product of Nikola Tesla genius, how it's working. And remember, it was invented more than 130 years ago. So if Tesla inventions were implemented at that time, or even later, we would have clean planet, we would have no pollution, we would have no climate change, and we would have energy as much as we need at any point in universe, anywhere, anytime, unlimited and free. This is exactly what Nikola Tesla devised, and this is what he invented. Once again, thank you very much for your attention. Oh,